Итак, мы продолжаем.
And as we continue, we proceed with the next presentation brought to you by Nikolay Averin of Emira, and he will tell you about PG repack and deferred constraints. Hello once again, I am Nikolay Averin, I am backend developer at Emira, and today I will tell you about how we use PG repack in Postgres. It was the case when we faced a problem, and I will tell you how we fixed a problem. So first I will tell you about bloat, so you could understand what we are talking about. As you know, multi-version concurrency control is at the core of Postgres. For each string in the table, there can be different versions. It allows to work transactions to work concurrently without any conflicts. Postgres uses page model while working with memory. Let's take a look at the example. Let's say we have a table and we got two rows in this table, and we've got some new data in this table. These are live tuple. Then we update an entry. We mark the previous entry as non-actual, and this is how we populate the entire page. Next, if we want to work with this table, we are going to use these pages of the file. But as we see, there are some dead data on the page. It's not a secret that there is a vacuum mechanism that allows to fix this problem. And this size can be reallocated if the vacuum is aggressive or it is busy with other tables. We will go to other pages. While working like this, we can have 4 tables like this. So we have 4 tables, and half of them are populated with live data, and the other part is dead data. This just occupies some size. There can be a query that can make the entire page dead. So we have more pages than we need. Then we make vacuum, we purge data, but the situation doesn't get better. We've got some empty spaces, and if we unify this situation, we will not be able to use this page until we purge these empty spaces. This empty page, if it was at the end of the file, vacuum could just cut it off, but in the middle, it will just stay there. When the number of such empty pages becomes too big, it can degrade your performance, and it is called bloat. I mentioned this on tables bloat, but in indexes the situation is the same. So what can we do with bloat? In order to do something with bloat, we need to understand whether we have bloat. You can find some ready-made scripts that can tell you whether you have bloat in a particular table or in the entire database. Here is the example of such scripts. If you want to get a more accurate indicator, you can use PGStatTuple extension. But in order to do so, you have to scan the entire table. 5 to 15% of bloat is okay. But if it goes beyond 15%, like 50-60%, it can affect your performance. What can we do? So first, you can use auto vacuum in order to avoid bloat completely. In real life, sometimes it is possible. Let's say you have an application under development. You create new tables, you modify current tables, you do some migrations or other operations, so your load profile changes a lot. You have to anticipate problems, and you have to fine-tune your vacuum according to the load profile. And different tables have different load. That's why these settings will be different table from table. If you wasn't able to avoid bloat, you have to tackle it. What do we have out of the box? We have vacuum full. It will only leave you live data. But the problem is access exclusive lock. When vacuum is operating, you can't manipulate with your database. If it is okay for you, then go for it. Unfortunately, we don't have a lot of time to do vacuum full. You can use cluster instead. It looks very similar. It leaves only live data, but you can specify a specific attribute, and sometimes this is a very good optimization. If we're talking about indexes, there is a reindex command. It looks similar, but it deals with the index-specific rebuild. The problem is the same with access exclusive log, but now we have concurrently starting from PG Postgres version 12. And it doesn't interfere with inserts and other commands. If you have an older version of Postgres, you can emulate reindex with create index concurrently. It appeared long time ago, and you can create an index without an exclusive lock. Then you can replace the old index with the new one, and then just delete the old index. And this is the only tool that allows you to deal with index bloats. But what can we do with tables? You can use different extensions. Some of them are on this slide. I'm not going to compare them and to choose the best one. I will only tell you about PG Repack that we use. Some theory how PG Repack works. Let's say we have a table. An ordinary table with indexes, constraints, and bloat. At stage number 1, log table will be created with all changes that happen when repack is working. Trigger will replicate those updates. Then a new table will be created. But this table will not have any indexes performance degradation. Then we just put table information from the previous table to the new one, and we have only live data in the new table. And during this replication, there will be some updates. Next step is to create indexes for the new table. Once the indexes are created, we just fit everything into the new table. At a certain moment, when there is not a lot of data, we can use an exclusive lock on the table. We can apply all other updates, and then we just replace tables. So this is the only short moment when you cannot work on your table, but it happens very fast. So the algorithm is almost over. All we have to do is to delete all the objects, and you will release some size in your system. Looks like everything is great, simple and easy. We started to test it with load, without load. We found that it is so tests were positive. At the first cluster, we got this error, and we got deferred constraints. So once again, some theory about deferred constraints, because this is not a very popular topic. Let's take a look at a very simple example. We have a table with the name and with the order number. And we use it to sort values while implementation. If we want to change records number 1 and 2, we can have such a solution. But obviously, there will be some errors with the constraints. What can we do? We can rewrite a query and add another update. And we will get an update through the third value, third variable, or we can just reconfigure a table in order to use floating point values. So we can change the number of the first entry, and this is how we can actually replace these entries. But for users, it will be a little bit different when they see a value with the point. And the second constraint is data type accuracy. You have limited number of inserts. The third option is to make a deferred constraint, and it will be checked at the commit stage. Since all values should be unique, at the moment of commit, the query will be successful and it will be readable. Therefore, given the type of constraint, there are three levels of granularity. Level of statement, transaction, and row. Check applies at the row level. For others, there are options. So given a situation, you can get bonuses, just like the code gets more readable. There are fewer commands, but you have to pay for it. Sometimes optimizer cannot build a more optimum plan if there are deferred constraints. And also debug process gets more difficult because when there is an error and when you get information about this error, they are different. Now I think you understand what it's all about, so the check is being performed later than the command. Okay, let's go back to our example. So we've got a problem here because in log table data are committed together with the bloated table if they satisfy with the constraints. But why did it happen? The problem is that the previous step, when we created indexes for the new table, I made a mistake. I missed a key because we are creating indexes only. If there were constraints, the new bloat will be created for indexes. If it was a unique constraint, we have to have unique index. So we have to do something to do all the checks at one moment. In order to understand the essence of the first solution, I have to mention what we are doing. We are creating something like a whiteboard for collaboration. So users can draw something, write something, add stickers, figures, or something like this. They can do it in a web browser, online, in real time. This is what our company is doing. Of course, sometimes there are some conflicts. Let's say two users are trying to edit one ticket. By the way, you can go directly to mirror.com to understand what I'm talking about. If they're trying to edit the same sticker, we have to understand who started to do it earlier. And what operation will be declined or executed, or a more complex case. When you work with a number of widgets and they overlap, we need to understand what operation to execute and what to decline. There are a lot of conflicts like this, and they are processed by different ways. Some methods are based on code. Some of them use these deferred constraints because the code looks easier with them. So when we're using such deferred constraints, it's okay. It doesn't happen all the time. When you do some optimistic updates, we get some errors, but we know how to deal with them. So therefore, the idea was to create a strict constraint, just like a deferred constraint, and it will trigger some false positive alerts, but it should be okay for a user. So you can do the same command a little bit later and it will be successful. We checked it and it looked fine. And during testing, we got just a few of such errors, which is okay. We went to production. We did it on cluster 1, just 5 errors within 1 hour. The result is acceptable. We went to other clusters, and on cluster 2, the number of mistakes was higher. Several dozens of errors. We decided to stop it. As I said, we tested this repack, and there were no problems. We started to think what to do. Looks like we got only 2 options. It's either we rewrite the entire code to avoid deferred constraints, or we learn PG repack how to work with these constraints. So we didn't want to rewrite the code. That's why we decided to do something with deferred constraints. The idea was simple. We just replace indexes with deferred constraints in order to check our modifications. We wrote a test. So we've got a table with one entry, and we simulate a conflict. Then we do an update, and we try to commit data. So the older repack version conflicts and crashes at the very first insert. Our version worked fine. We go to prod, and the same mistake. Looks very weird. It's one of these typical situations when everything works on test, but nothing works on prod. We went to PG repack, and the error occurred at the same stage, and so it was like a batch update. Apply count is the batch size. This is the essence of the problem. If you have several operations that can conflict, it can find itself on the edge of two batches. So everything, if you are lucky enough, you can get this mistake or not. So here we just added another update, and PG repack stopped working. So it was clear that we do something that data that we had in the original table, we needed to put them into the transaction. There were two options. What if we just get rid of batching? What if we do just one big transaction to feed data to the new table? We didn't have to rewrite the code, not a lot of modifications, and there were no conflicts. But another problem is we are making a very long transaction. Option number 2, more complicated. What if we do it differently? And we applied a certain method just to control our transaction. First, we wanted to test the easier option, an easy option. We didn't make a lot of corrections. We tested it on production, and that's it. Everything was successful across all our clusters, and this is one of the examples. So what comes next? A few recommendations and a few conclusions. You have to monitor your bloat. By doing so, you can understand whether auto vacuum works well. If auto vacuum doesn't work well, just fine-tune it. If bloat happened and you cannot fight it with vacuum, you can use a proper tool in order to do so. If you are using external extensions, don't be afraid of using them. Don't be afraid of improving on refining these solutions. Don't forget to test them. Talking about our modification, we want to discuss both solutions with developers and to find a better one. And I'm hoping that in the future this request will be executed. Should you have the same problem, just mail me and I will send you this patch, but it's up to you whether to use it or not. Thank you for your listening, and I'm ready to answer your questions. Questions? Thank you very much for your talk. I forgot about another table bloat extension. It works, I don't remember the name. So upper tuples are being updated and they go lower to the table, and then the table launches vacuum. It doesn't create a second table. And there will be no problems with deferred constraints. Why didn't you use it? You're talking about autocompactor, an extension that allows just to cut off tails. Why we didn't use it? The problem was, first the repack was applied for other tables, and it was okay. If we're not using deferred constraints, there were no such problems. So if it works, why should we use another tool? And we decided to use the same tool for other tables, and we faced problems. There was an idea to get rid of this tool, to replace it, but after some iterations, the problem was solved. So yeah, maybe if we didn't do it, or if we did something but it wasn't okay, we would go for other extensions. There's another problem that in order to put this data into the beginning of the file, you have to do a lot of updates. And if the table is fragmented, all data will have to be relocated, and I think that overhead will be higher than while using PG repack. But you didn't test it. We have to compare. Did you test it? What's the overhead? It will be IO overhead. Did you test it? No, we didn't. Thank you for your talk. Not a question, but maybe an explanation for the previous question. In our experience, pgtable and pgcompact did not remove bloat correctly in toast. It could be one of the reasons why you should go for PG repack. Thank you very much for your remark. Looks like we've got no more questions. Should you have any additional questions, please find me at the conference. Thank you for your listening.